Hello, we are Group 12 for Avionics Presentation 1. My name is Ishan Mitra Haldar. My metric number is 201390. Vinod.
I'm Vinod, son of Magindran. My metrics number is 202789. Wafi?
My name is Nur Shaira Atifah binti Kanira with my matrix number 202468.
My name is Lokman Wafi bin Khalid, metric number 200269.
My name is Muhammad Faizal bin Wahidudin. My metric number is 203137.
We will proceed with the introduction. So this is presentation for EAS 3622 Avionics, Group Assignment 1, Avionics in Civilian Aircraft, and we are Group 12. Our topic is Crash Safe Flight Data Recorders, CSFDRs. These are the metric numbers and the names of the group members. Introduction. We'll take a glimpse into the CSFDRs. It is commonly referred as black box or misnomer black box, even though it is bright orange in color to make it easier to locate in a crash site. It is located in the tail part of a plane and powered by batteries. It has two main components, CVR and FDR. CVR is cockpit voice recorder and FDR is flight data recorder. CVR collects all kinds of sounds inside our aircraft for 2 hours, and that is its main usage. And FDR measures data on various aspects of a plane's performance, and it uses flight data acquisition unit, which actually is consisting 88 different performance parameters, and all these data are sent to FDR storage. A brief history of CSFDR. It was first thought by a young Australian scientist and researcher David Warren in 1953 because he thought that a device which can actually collect some data from the airplane can be very important for the investigators in case of a crash, and he made his device by 1957, and his device was called a flight memory unit. And even though it wasn't used that time, but in 1960 there was a crash in Queensland, and after that Australia became the first country in the world to make the black box mandatory for all commercial aircrafts. Now, what is the difference between the previous one and the newer versions of CSFDR? The early recorders could only log in the basic flight conditions like heading, altitude, airspeed, vertical acceleration, and time. But now it can actually go for many more parameters, including throttle and flight control position. And the earlier versions actually used a steel foil to record the data, but now we are using solid state memory to record the data, and it can be downloaded instantly. And previously flight data recorders could break easily. To prevent that, we go for more testers, and now they are very durable. What is the future of the CSFDR? The future is mainly thinking of including a transmitting device, so that even if a plane crashes, we don't have to find the black box, but we will get the data. And the technology is actually being used by NASA already. And in 2007, US light aircraft manufacturer Low Prestige Speed Merchants announced that it planned to fully integrate MP3 players as flight data recorders on all of its Fury piston aircraft. So these are the two main suitable thinkings or future steps for CSFDR. We'll move forward to the next presenter.
So I'm going to present about working principles. The first one is power supply. Both FDRs and CVRs run off a dual voltage power supply, which gives the unit the flexibility to be used in a variety of aircrafts. The batteries are 6 years of shelf life, with recent developments in power conversion technologies and market trends that are driving those technologies toward further miniaturization and greater integration. So this need motivates the investigation of black box models which require little or no knowledge of the internal workings of a system for those areas of industry adopting power supply technology as a point of load solution. Next. Yeah, we can see here the images of the power supply. It is placed at the back of the black box. Next. And the second thing is controller board, acquisition controller board. This board contains the electronic circuitry that acts as a switchboard for the incoming data. The GPS accuracy in small UAS can be degraded by several sources of errors such as satellite clocks, satellite orbits, and Earth's atmosphere, and multipath errors and the receiver itself. The accuracy of GPS receivers and the inertial navigation system that allows for stable flight paths in small UAS used as a georeferencing sensor platform should be ascertained first. Okay, now, so can a regimen be formed to assess a UAS for platform stability, path accuracy, and spectral sufficiency? How can a DPS be implemented to assess the accuracy of UAS platform sensor performance? With flight data and ground control point, coordinates obtained for each marker from real-time kinematic GPS, the basis of a testing regimen is formed using a DPS. A result is the definition of a spatial proximity method to use for an accuracy assessment regimen. Next. Yeah, so this is the controller board, aircraft interface board, audio compressor board, and acquisition processor board. That's all.
Okay, my name is Luqman Wafi, and this is the memory unit of crash safe flight data recorder. This is the protection barrier of the CSFDR. We'll start from the inner side. The first barrier is the aluminum housing, which is a thin layer of aluminum that surround the memory cards. The second barrier is the high thermal insulator, which is 2.54 centimeter thick silica material. It is the thermal protection barrier of this memory unit. And the outer part of the memory unit protection barrier is stainless steel shell. The stainless steel shell is about 0.64 centimeter thick. Next, this is the quality testing for memory unit. First, crash impact test. Second, pin drop test. Third, static crash test. Fourth, fire test. Fifth, deep sea submersion test. Sixth, saltwater submersion test. And lastly, fluid immersion test. This will be further explained by Vinoth after this. And lastly, for the underwater locator beacon, which is ULB, the function is to inform its location underwater. It is because this ULB transmit 8.8 kilohertz of pulse. And for power source, it uses single cell type battery. For the installation, it need to be installed at the rear part of the aircraft to avoid direct hit when the aircraft crash. For the advantage, it is a low frequency device that has a long detection range. And for the disadvantages, it operates at the maximum depth of 6,000 meters and transmit an acoustic signal of 8.8 kilohertz for at least 90 days. That's all from me.
Okay, I'm Vinod, and I'm going to start presenting about the testing methods. Okay, so the reason we need to carry out the testing methods, because one, it's so that it can be certified by the manufacturers. This certification is very important in order to gain the public's confidence. Without certification, the public would not be willing to board on a aviation plane. And of course, we need the black box is very important in case of an emergency. Okay, and there are 7 testing methods which can be carried out to ensure the black box matches its standards. Okay, so I'm going to go to the first one, which is the deep sea submersion test. Okay, in the deep sea submersion test, what is it's done is the black box is placed in a container which mimics the ocean environment. Okay, so in this tank, it is pressurized and the black box is only kept for 24 hours span. Okay, and this is to measure the pressure sensitivity tolerance and the structural integrity of the black box. Okay, the next test is the crash impact test. During the crash impact test, what is done is an air cannon is shot onto the black box, and the pressure that is the black box received is as much as 3,400 GS, which is the equivalent of the pressure that a black box would receive in case a real event of a crash. Okay, so the next crash, as you can see in the video, is the pin drop test. Okay, so the other name of the pin drop test is the Rockwell test. What it's done is a sharp object is placed under the weight and the weight is dropped right onto the black box. And during this test, it's to measure the durability of the black box in all in case of an impact. The next one is the static crush test, which is as similar to the pin drop test, but what varies here is that this is time dependent and the weight that is placed onto the black box is 10 times the weight that you was shown here. Okay, so of course, both tests is to measure the penetration resistance. One is time dependent, the other is not. And now we're going to go to a fire test because in case of a crash, the airplane is very prone to get fire and catch fire. Okay, so what they do is they shoot a fireball, an environment that stimulates as much as 2000 degrees of Fahrenheit. Okay, the main purpose of this is to make sure that the memory module can withstand that amount of heat, since the memory module plays a very important role in storing the data and the information. So yeah, the fire test is carried out for 1 hour. Okay, after that is the salt water submission test. This is done by placing the black box into an unpressurized water for 30 days, and this again tries to mimic the calm ocean, and its main reason it's done is to prevent corrosion. But as you can see, this varies from deep sea submersion test, which is only carried out for 1 day. And in saltwater submersion test, it's done for 30 days. And deep sea submersion test is unpressurized and it's pressurized. It's unpressurized here and it's pressurized in deep sea submersion test. Okay, and now we're going to go to fluid immersion test. And in fluid immersion test, what it's done, it's not going to be, the black box is not going to be submerged into normal water. It's going to be submerged into other than seawater and normal water, such as jet fuel, lubricants, and fire extinguisher. This can be classified as avionic fluids. So the black box is submerged into avionic fluids because to reduce corrosion that may form in the depths of the ocean. And now I'm going to proceed with the manufacturing process of the crash safe flight recorder. Okay, so there's two important factors that determines the manufacturing process. It's to measure the indestructible component of the casing and the inside components. Okay, as you can see, the protective casing, it encapsulates the entire memory unit, power supply interface board, and the underwater locator beam. So it's actually built separately to help assembly and disassembly of the black box. Okay, now we're going to go for the memory unit, which is the most important part of the black box. The memory unit, it stores data and everything. To protect this, there's the steel plate, which is the casing and its outermost layer. And a little bit info of the memory unit is that it stores 2 hours of audio, digital, and timing information. Okay, and again, to protect the memory board, a cushion is placed in between the casing and the memory board. This cushion is normally a paraffin. Paraffin is normally a cushion used because paraffin is an intelligent material. We can change its state according to temperature. So if the black box is exposed to a hot environment or a cool environment, the paraffin can change its structure and provide insulation to the black box. And as you can see during the assembly, the casing is bolted, the power supply is screwed on, the power supply has a handle which makes it easier to hold the black box, and then the memory unit is fixed inside. And finally, the black box is colored orange so that it can be visual. In case of a crash, you need to locate the black box, and so it's colored orange. That will be from me. Thank you.
My name is Atifa and I will be presenting about data obtaining process. After finding the black box, the investigator take the recorder to the lab where they can download the data from the recorder and attempt to recreate the event of the accident. Then it will be divided into two categories, which is the first one is the data not damaged and data was damaged. If the flight data recorder is not damaged, the investigator can simply play it back on the recorder by connecting it to a readout system. With a solid state recorder, investigator can extract raw data in a matter of minutes through USB or internet port. But if the FDR is damaged, the memory board are removed, cleaned up, and have a new memory interface cable installed. Then the memory board is connected to a working recorder. This recorder was special software to facilitate and the retrieval of data without the possibility of overwriting any of it. For the cockpit voice recorder, a team of experts is usually brought in to interpret the recording store. Thus, this bot attempt to interpret the 30 minutes of the word and sound recorded by the cockpit voice recorder. This can be a painstaking process that may take weeks to complete. This is the output of the black box. Sorry for the wrong for this section where it said the flight cockpit voice recorder. This is a flight data recorder. Flight data recorder is information is typically presented in a form of graph or animation used to understand the instrument reading, flight characteristic, and the performance of the aircraft during its final moment. While for cockpit voice recorder, it will record the audio of the environment in the flight deck. And then this is the we will learn I will present about the difference of crash and result. Crash result on the land and sea. For the land, the black box is transported to the computer lab at the National Transportation Safety Board. Then it was translated into a format readily usable by the investigator and the critical in identifying the probable cause of the incident. In addition, outside experts are also often consulted to help the analyze and interpret the data. But for the crash on the sea, the beacon send out an ultrasonic pulse that cannot be heard by human. The beacon send out pulse at 37.5 kilohertz and transmit the sound SD at 40,000 feet. A battery that has a shelf life of 6 years to power this beacon because the beacon begin pinging its ping once per second for 30 days. When the recorder is out of the sea, the recorder are placed in the cooler water to keep them from drying out. And then for the cases for MH17 incidents, this is the data taken before and after the crash. This is the data of the flight data recorder, and this is the data for cockpit voice recorder. From the picture, we can conclude that the data from the flight data recorder and digital cockpit voice recorder both stop at 1:20 per 3 second PM. And when the controller asks Malaysia 17, how do you read? It's saying it's disappeared. Then another air traffic controller on the same radio frequency saw the plane falling apart. In conclusion, there would be nothing usual but before the explosion, and the explosion most likely stopped power and so the recording. That's all from me.
Okay, now the MH370 incident, the most one of the shocking incident to the aviation world. Okay, the Australian Transport Safety Bureau Accident Investigation Lab is the place where the black box from the Malaysia Airlines flight MH370 could have been brought, because since it's the nearest place and the place that may play a critical role in solving the mystery of what happened to the Boeing 777 and the 239 passengers and the crew on the board. Once the flight data recorder or cockpit voice recorder is retrieved from more than 4.5 kilometers below the surface of the Indian Ocean, it will be packed in water in a plastic bin to stop any salt or chemicals from solidifying and damaging the memory board. The only part of the flight data recorder that investigators really need intact is a small rectangular box called the Crash Survivable Memory Unit. And this is where the vital data and the potentially the answers live. In the case of the Boeing 777, the flight data recorder captures about 2,000 parameters for up to 25 hours. Some of the key parameters are recorded as often as 8 times per second. When the raw data is downloaded from the recorder, it comes out as a binary computer code, a slew of zeros and ones. Using a document provided by the aircraft manufacturer, investigators are able to decode each piece of data and begin the process of getting a clearer picture of what happened to the flag. Closure that any investigator, wherever the black boxes from MH370 end up, might hope to bring the loved ones of those on board missing of the Malaysian Airlines flight. That's all for me.
And for the 9/11 incident, there are 4 airplanes involved that were hijacked. 2 airplanes were crashed at the Twin Towers of World Trade Center. 1 airplane crashed at the Pentagon outside of Washington, D.C., and 1 airplane crashed at the field in Shanksville, Pennsylvania. In this incident, there are about 3,000 people were dead, and I put a link here if you want to hear the voice of the flight attendant, passengers, and the hijacker. So in this link, it is from the air traffic control tower. But as we know, the voice recording from the air traffic control tower will somehow be slightly the same as the black box. So if you want to hear the voice, go check it out at the link. That's all from me.
All right, so we'll proceed to the conclusion. In the safest year of air crash by International Air Transport Association was 2015, where there was only one crash for every 3.1 million flights worldwide. But as we can see, there are still airplane crashes. So we still need black box. But from the incident of 9/11 and MH370, we know that we need to upgrade the black box from its current position. There are the NASA's transmission device, then the MP3 player by Lopere, but there is another one. The Flight Aerospace Solution in Canada will provide the streaming service, and it activates when an abnormal occurrence happens and then quickly sends the torrent data to the airliners for analysis. So we don't need to find the black box anymore. If we use this, we can just go for the transmission. And therefore, the evolution of CSFDRs will continue in order to ensure an even better service in case of an undesired incident. That will be all from us. Thank you so much.
Thank you,
Thank you,
Doctor.
Thank you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doctor.